All right, let's go ahead and get started. So 3.2, what we're going to be talking about is characteristics of discrete relations. Now first, let's talk about what is a discrete relation. Discrete data is disconnected Discrete data is disconnected data. The input variables are going to be isolated, distinct, and individual. Then that second bullet point says discrete data, what that means is that the values between the points don't exist. So there are going to be no partials when we are talking about discrete data. And I've given you a little coordinate grid over here with this would be an example of a discrete scenario. Because if you go to Crumble Cookie, are they going to let you buy 1.5 cookies? Are they going to let you buy 1.25 cookie? No, there are no partials. You have to go there and buy 1 cookie or 2 or 6 or 12, right? There are no partials. So this would be an example of a discrete scenario. So if we were to graph it, this would be something like, okay, I go in and 1 cookie there is going to cost me $3. 2 cookies, $6. 3 cookies, $9. 4, $12, whatever, so on and so forth, right? And we have these individual distinct points because these values in between them, we wouldn't connect them because these values don't exist, right? If the x-axis is my number of cookies, we just said I can't have 1.5. I either get 1 or 2 or 3. So because there's no partials, because the data in between is not real, is not there, we would leave them as distinct points and it would be discrete data. Okay? You can think of discrete data as anything that can be counted, right? You can count the number of cookies, you can count the number of students in the school, you can count the number of shirts you have in your drawer. So if the data that you're looking at can be counted, then that's going to be discrete data. All right? Now, since discrete data is disconnected, these numbers can be listed, right? We can list things that can be counted. So the characteristic that we're going to look at with these discrete functions is this domain and range. The definition of domain, you guys defined this last week, but domain is going to be the set of all x values. So when we're talking about domain, we're talking about what are the x's in the function. And when we write the domain of a discrete function, all we're going to do is list all the x values, and we're going to list them in order from least to greatest. We'll separate those values by commas, and then we're going to put these pretty little brackets at the beginning, at the end, to show that they represent a set of numbers. All right? So domain is just the x's of our function. So if domain is the x's of our function, what do you think the range is? There, very good, very good, very good. Range is a set of all y values. So again, when we're talking about range, we're talking about what are the y's. And we're going to write the range just like we would write the domain. We're going to write it as a list of all those x values. We're going to put that list in order from least to greatest. We'll separate it with a comma, and we'll use those pretty little brackets to group them together, okay? So here we go. We're going to look at 5 different examples. We're going to state the domain and range, and then we're going to determine if it's a function or not. So I'm going to pull back in a little bit of 3.1 just so we get more practice with that. All right? Number 1, I have given you a mapping diagram. Remember this oval, the left oval is your x's, the right oval is your y's. So since this is a discrete function, again, this domain, we're just going to list the x values that are in this mapping diagram. So we'll do the little brackets, and we're going to list them in order from least to greatest, which luckily they're already in. So our domain is just 1, 2, 3, 4. because domain just means X values, and the X values are listed in the oval. So you just write them as a list. So then for our range, same thing, except this time, now we're looking at what are the values in the Y oval. So the values in the Y oval, I use letters this time instead of numbers, but that's okay. Those values are A, B, C, and D. See how easy it is? Domain, list the X's. Range, list the Y's. That's it, okay? Is this mapping diagram a function? Yes, it is. Each of these X values only has one line or one arrow coming from it, so that means it's a function. All right, number 2. We're gonna doctor this graph a little bit because I don't like these 2 points, so my bad. But we're gonna change these 2 points so that they sit directly on a coordinate grid. So I'm gonna move this one over here, and I'm gonna move this one over here. I wish there was a way I could change. So this one no longer exists, and this one no longer exists. So we have these 5 points. Everybody with me? Sorry about that. Okay, so now that our points are on coordinates, it's going to be a lot easier for us to list the domain and range. So remember, domain and range are in order from least to greatest. This x-axis, think about this x-axis as a number line, which means least is going to be to the left, and then greatest is going to be to the right. So I'm going to look at these points from left to right so that I make sure that those x values are in order from least to greatest. So this is my furthest left point, and it has an x value of -4. So that's going to be my first one. Then as I keep moving to the right, here's my next point. My next point has an x value of -3. Then as I keep moving to the right, here's my next point. This point has an x value of -2. Then I keep moving to the right. Here's my next point. It has an x value of -1. And then my 5th point on this graph is right here now, which has an x value of 0. So when you have points on the graph, just look left to right and use this x-axis like a number line and just what is the x value of each of those points. Okay, that's your domain. Then your range, well now we're looking at the y-axis. So if they have to be in order from least to greatest, we need to look bottom to top, right? Lowest to highest point. So our lowest point is going to be right here. And now again, I'm looking at the y-axis as a number line. This point has a y value of 1. So that's our first range value. Then as I move up, well, now I have 2 points with this y value of 4. Please don't list it twice, only list it once. So my next y value would be 4. And then as I keep moving up, well, now I've got these 2 points. Both of those points have a y value of 7, so I'll just write it once. And then I'm done. Those are the 3 y values from that graph. Is this graph a function? Yes, it is. Remember, we're looking, do any of these points sit directly on top of each other? No, they don't, so it's a function. All right, graphs are probably like the hardest ones, because now let's go to tables. A table has an x column and a y column, so it's just as easy as the mapping diagram. Your domain are going to be these x's, and your range are going to be these y's, and they're already there for you, so you are literally just rewriting them. The domain are the x values 2, 7, 8, 11, 15. And then the range values, so now I'm just listing those y's, 5, 8, Be careful here because it needs to be 12 and then 15 and then 19. Is this table a function? Yes, it is. None of those x values repeat, so it's a function. All right, last two. Number 4 is the same set of ordered pairs I gave you in the warm-up today. Remember, with these ordered pairs, they are always x, comma, y. So if the domain is listing the x's, we're just listing what's that first number from each ordered pair. 1, 4, do not repeat 4 again, 7, and 11. So if they appear more than once, still only list them once. Then your range. So now I'm just listing the y values. 2, 4, 6, and 9. And we already determined this today. But are these ordered pairs a function? No, they're not. All right, last one. We got a little story. It's perfect for the time of year. Riley is going to a pumpkin patch and is going to pick up 1 to 3 pumpkins. The function y equals 12x plus 20 represents the total cost, y, that it costs based on the number of pumpkins, which is your x. Fill out the table for the situation to help you determine the domain and range. So, remember, we've got 2 variables, x and y. X is your domain, range is your y, and this story tells us what both variables represent. It says that the total cost is y. So over here on the y, we've got total cost. And then it tells us that the number of pumpkins is our x. Now, what's this story problem tell us about Riley and the number of pumpkins she's going to get? What's it say? She's going to pick up how many? 1 to 3. So the possible number of pumpkins are going to be 1, 2, and 3. And this is a discrete situation because, again, when we go to that pumpkin patch, you're only buying 1 or 2. You're not going to buy 1.5 pumpkins or 1 3/4 pumpkins. You're buying 1 or 2 or 3. So that's going to be our x values, which is our domain. So that's easy. Now, for our range values, we got to do a little bit of work because we need to know what's going to be our total cost if I buy 1 pumpkin. What's my total cost if I buy 2? What's my total cost if I buy 3? Well, they've given us this function. Y, which is the total cost, is equal to 12 times x plus 20. And now I have 3 values of x. So if I want to know the total cost for 1 pumpkin, I'm going to do 12 times 1 plus the 20. So 12 times 1 plus 20. 12 times 1 is 12, and then 12 plus 20 would be 32. So that's the cost if she buys 1 pumpkin. Now I'm going to use that same function to figure out what if she buys 2. So we're going to use the same function and do 12 times 2 this time plus 20. Yep. So 12 plus 2 is 24, plus the 20 I heard over here is 44. So that's our next y value. And then last but not least, we would do 12 times 3 plus 20. So 36 plus 20. Very good. So we had to do a little bit of work there, but it wasn't too hard. And having this table hopefully helps you to see that now my domain, that's the number of pumpkins, so I'm just going to list my domain as 1, 2, and 3. And then the range, because range is Y, the range is the total cost. And we found these total costs in our table. So that means that the range would be 32, 44, and 56. And then pretty easy, but does this story problem represent a function? Yes. Each of those x's only have one y. All right?